Let's discuss and prove the chain rule. In this case, we are going to have two functions. Let's have two functions. F continues in AB and differentiable at some point x in AB. That means that the derivative exists. Or let's say that G is defined on some interval I such that the range of F is contained in I. We will also require that G is differentiable at f of x. Okay, under these conditions, then we can guarantee that h of t, which is the composite function g of f of t in the closed AB, is differentiable at the point x, and the derivative is g prime at f of x times f prime of x. The classic chain rule. This works, of course, for real functions. In higher dimensions, the chain rule looks a little different. Okay, so here again we have our AB, and then our function f is taking it somewhere in the range that is contained in I. And then G is taking I into the real numbers. So for example, our x is mapped to f of x, which is in I. So it's in the domain of G, and then we can apply G and map it to G of f of x, which is h of x. Okay, so for the proof is actually quite simple, and we are so used to the chain rule that it looks a little magical when you see the proof, and actually the chain rule comes out of nowhere. But of course, that is because we are very used to the chain rule. The first place we saw it was probably not so natural. So it's defined like that because that's what comes out in the proof. So to check the differentiability, we need to compute the limit of h of t minus h of x divided by t minus x. And here we have no choice but to write down what h actually means. G of f of t minus g of f of x divided by t minus x. And here we are going to, you see, because there is a mismatch, here inside G we have f of t, f of x. Okay, but we are dividing by t minus x, so doesn't quite match the information we have on the derivatives of G and f separately. So what we do, we are going to multiply it and divide by what? So we are going to take what is inside of G here, you see? So f of t minus f of x, because when I divide by t minus x, I almost have a derivative there. And then I divide by the same thing, and I will have to figure out that part. Okay, but I do that because now I can just take limits. Okay, the second part, as t tends to x, clearly tends to the derivative, f prime of x. But then the first part, as t tends to x, converges to the derivative at f of x. And this happens, and it's important to note this, happens because f of t is continuous, and therefore it converges to, f of t converges to f of x as t tends to x. Okay, this is by continuity. So then what we have here is f of t minus f of x. Okay, these two is what we have downstairs. Actually, I wrote g here, but it was f. Now it's good. Okay, so it's the same format as the definition of derivative. And here we have the product of g prime at f of x times f prime of x. And this finishes the proof of the chain rule.